Okay, why don't we do the weight and balance screen here? There's an interesting thing or two here. We're in the wonderful Cirrus SR-22 airplane. And what we enter up here in the left is a longitudinal center of gravity. Now, some people ask, well, what's your reference point? And here's the weird thing about reference points. The reference point in PlaneMaker can be anything you want. Just use the same reference point for everything you enter. Some aircraft designers use some point in front of the airplane as the zero reference point. Some might use the firewall. That's an easy one. But choose any reference point you want in the airplane and enter all of your longitudinal, vertical, and lateral arms with respect to that reference point. So whatever reference point was chosen by the modeler to make this airplane, and that modeler might have been me some number of years ago, we've got a longitudinal center of gravity. Negative 0.15 is the forward limit. 0.70 feet is the aft limit, and the empty aircraft is at 0.15, the forward limit. I don't guarantee these numbers are actually accurate because I don't want to risk saying anything inaccurate about a Cirrus SR-22, although I have owned one of these airplanes, owned it for many years. It's wonderful, wonderful to fly. But at any rate, you'd enter a longitudinal forward limit, aft limit, and empty center of gravity as well. Now, here's what's kind of interesting. What PlaneMaker will now tell you is where that center of gravity is in percentage mean aerodynamic chord. So what's the mean aerodynamic chord? The mean aerodynamic chord is the average light chord of this wing. I guess maybe I should say mean rather than average, but I think they mean the same thing. But it's that average chord of the wing, and then the center of gravity is shown here as a percentage of that. So a 0% mean aerodynamic chord would be right up here where the mouse is, right up at the very front of the average chord, and a 100% mean aerodynamic chord would be all the way at the back. And we have found from experience with airplanes that we want our center of gravity to be somewhere around the 25% mean aerodynamic chord, plus or minus, because that's where the wing is really thought of as operating. A wing operates as if it's rotating about a 25% chord. And what do you know? Our mean aerodynamic chord has a forward limit of 9.87%, which is clearly the forward limit is right up here, right? 9.87% of the way back. And the aft limit is 31.65%. What do you know? Just a little bit, about a third of the way back, just a little bit behind the 25% mean aerodynamic chord. So what's kind of cool about this is I figured out the mean aerodynamic chord percentage of center of gravity location for you, so you can get a sense of whether or not your CG is around the 25% chord, which is more or less what you want, plus or minus. Down here in the weights, we've got the empty weight, which you can figure out to do that the fuel load. Then you have the JATO weight. That's the jet assisted takeoff, which I understand Cirrus SR-22s don't have. But if your airplane does, you can have a solid fuel rocket motor to punch you up like Fat Albert does for the Blue Angels. Google that if you don't know what I mean. Fat Albert of the Blue Angels. Then you have a jettisonable load. This would be like a water tanker airplane that drops water on forest fires. How much can you jettison? The maximum weight, I think we know what that is. And the weight shift weight. Well, this is if you're doing a hang glider. It's how much you weigh is you like shift your weight around. So that's kind of funny. And displaced weight, that's how much weight you can displace if you are a dirigible. Then once you start, saying, oh, well, if my maximum weight is a slung load, well, where does the slung load attach? And how long is a cable that attaches it? Enter it here. If it's a pipe rather than a line, as helicopters use to hang a chainsaw down below the helicopter to trim branches near power lines, we'll enter that here. If it's water, enter the location of the tank, which I think is used for the center of gravity. And if it's another airplane, because one airplane carries another, aka a B-52 carrying an X-15, you can enter your attachment data here. The radius of gyration of a body is like how much inertia it has in rotation. It's like you can think of the mass as being this far from the center of gravity. So let's say that our radius of gyration and pitch was 10 feet. Well, then that means you could think of the mass of the airplane as being set to be like a point that's 10 feet from the center of gravity. And so that gives you a sense of how much inertia it is. So imagine holding some dumbbells and trying to, do this with the dumbbells. Clearly, you're going to feel the inertia of those weights on the end of the dumbbells. So you can use your own if you know what your radii gyrations are. And if you don't, no problemo. Don't check this box. I'll figure out the radius of gyration for you in X-plane by looking at the size of the airplane and where the wing skin is and engines and fuel tanks and even landing gear and all sorts of stuff like that to really get a good radius of gyration estimate for you. So that is the weight and balance screen. Weight and balance tab.